Okay, in IIT JEE in 2002 they asked this problem. There's a pendulum, there's a string, and there's a bob. It is undergoing to and fro motion on in a circular path. Okay, the question is, which of the following correctly gives the direction of acceleration? In the first case, acceleration direction is this. In the second case, the acceleration direction is this. In the third case, they were given the acceleration direction as this. And suppose in the fourth case, acceleration direction is this. So which of the following is the best, can be the best description of the direction of acceleration at the given moment? A, B, C, D. See, this is the direction of centripetal acceleration. Apart from this, there will be some tangential acceleration. So this is wrong. This is the direction of tangential acceleration. There will be centripetal and tangential acceleration. So this is wrong. This is not the direction of any acceleration. This is wrong. This is the centripetal acceleration and this is the tangential acceleration, and the vector summation will be lying between these two vectors. So this seems to be better than the other three. Okay. Now this problem was asked in IIT JEE in 2000. Suppose there's a rod and there's a bead, right, on the rod, in the rod, and the distance of the bead from one end of the rod is L, and suppose the rod is given some angular acceleration to go in a circular path about this point. Okay, the angular acceleration, suppose, is alpha. The coefficient of friction between the bead and the rod is mu. Now they are asking, after how much time will the bead starts to slip on the rod? So they are asking the time after which the bead will start to slip on the rod. It's a good problem. Spend some time and get your answer. See, there is some friction force, and that friction force should act as a centripetal force. Friction force is mu times normal reaction, right? And there is some angular acceleration alpha, then we know that the tangential acceleration is equal to r into alpha. Fine. This tangential acceleration should be provided by the normal reaction. The normal reaction should be equal to mass into r into alpha. So friction should be equal to mu into m into r into alpha. This friction should act as a centripetal force. Centripetal force is m into omega square into r. R here would be, of course, the L. So from here, see what we are getting. We are getting that omega is equal to root over mu into alpha. Now omega final will be omega initial plus alpha t. We know this equation is starting from rest, so this is 0. So time would be omega final upon alpha. Omega final is this upon alpha. That will be root over mu upon alpha. This is the time after which the bead should start to slip. It's a good problem. If you didn't get it in the first time, you should think about it. Spend more time about it thinking. Why we took normal reaction to be mr alpha. Now very quickly, what's happening, I'll tell you what's happening here in this problem is there's a hemispherical bowl and there's a bob kept at the bottom. Now the bowl starts to rotate about its own axis. So the bead also starts to rotate, and obviously it will come up. So the angle that the radius would make when it passes through the bead with the vertical is given as alpha. The radius of the bowl is given as r. Now you have been asked, if this is alpha, if the angle with the vertical is known as alpha, then you have to find with what angular velocity the bowl is rotating. Right? So get your answer and then look at the answer. The answer would be G upon R cos alpha. Now finding that is pretty damn easy. This is the normal reaction, this is mg, and this angle is theta or alpha, right? Now you can see that n sine alpha is equal to m r omega square, and this small r is capital R sine alpha. So we can write this as m r omega square sine alpha, and n cos alpha is equal to mg. You just have to divide it and you can see that 1 upon cos alpha is equal to omega square r upon g. You can find omega from here. You will get this.